Hello, everyone. Let's work on problem 10.11, excuse me. So the problem statement reads, determine the maximum dead and life loads that can be supported by the compression member showing in figure, um, this figure here, okay? The life load is twice the dead load. So we need to establish something. We need to know that the life load equals 2 dead load. That's something we need to work on. Now, we have a column with constraints hinge and hinge. So then to find the K, you need to go to the K table from my previous lecture. And for a hinged hinge column, you should be able to find the K value. The good thing is that the section, the shape type is given, which is W12 by 79. So then if you go to 2 pages from the appendix, page 436 and page 440, you should be able to find all these values, the area of the section, the RY, and this value and this value from these 2 pages. And then we compare again this value and this value to from table 10.1. We know because it's a W section, it has the strong size and the weak side. So we have to consider and compare to know that to understand if the column is non-slender column or a slender column. So it just happened, just a plug-in chug, right, from the table 10.1. You have 0.56 under the radical modulus of elasticity over Fy, and 1.9 under the radical modulus of elasticity over Fy. It happens that these values are larger than these values, which means our column is non-slender. Now also we know K equals 1 from our table. So then the slenderness ratio, plug in chug, K1 times L12 times the 12 conversion to inches over the RY found here. It's below the 200, so our condition is adequate because it's under the 200, so the code allows us to work with it. Then from table, I believe, 10.3, we find this value, or you can just plug in chug. We find that this value is actually larger than the slenderness ratio, which means our column fails under the inelastic buckling mode. So then because of this, we find the Fe, which is pi squared times the modulus of elasticity over the Euler buckling equation, or the slenderness ratio gives us this value for Fe. Then we plug this value into this equation here to find the stress, which is 42.84 KSI. So our PU, or the capacity, plug in chug here, phi is 0.9, stress is 42.48 times the gross area from here. It gives us 886.98 kips. So now remember, we want to find the dead load and life load, and our life load is 2 dead load. So 1.2 dead plus 1.6 times, this should be life load, right? 1.6 life load, the load combination. So we substitute the L by the 2D equals the capacity. So then just a simple simplification, mass simplification, the dead load is 201.59 kips. then we just multiply this value by 2, and it gives us the life load, and this is how we find the answer.